Some local jurisdictions limit the use of tandem breakers in new construction. For example, the Los Angeles County Building Code prohibits the use of tandem breakers in new residential and commercial buildings, specifically Section 330.13. In contrast, the New York City Building Code allows tandem breakers in new construction, but they must be listed for use with the specific type of panel board being installed, as stated in Section 334.44. Seattle, Washington requires all tandem breakers to be identified with an orange handle and labeled tandem according to Section 334.44 of their building code. The opinions of authorities having jurisdiction or odds on tandem breakers vary. Some AHJ believe that tandem breakers are inherently unsafe and should not be used in new construction. Others believe that tandem breakers are acceptable if they are properly installed and labeled. In general, it is not advisable to use tandem breakers in new construction. Tandem breakers are more likely to trip nuisance trips, which can cause inconvenience and safety hazards. They also make it difficult to identify which circuit has tripped. Instead of using tandem breakers, consider installing a larger panel or leaving space in the panel for future expansion. This will provide more flexibility and reduce the risk of electrical issues. There may be instances where the use of tandem breakers is necessary, such as in retrofit situations or where there is limited space in the panel. In these cases, it is important to follow the manufacturer's instructions and use tandem breakers that are specifically designed for the type of panel board being used. When considering electrical panel installations, remember that codes and best practices prioritize safety and functionality. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent hazards. Article 100 of the NEC defines terms and provides essential definitions that are crucial for understanding electrical codes. Article 110 covers the requirements for electrical installations, including general requirements for safety. Chapter 2 of the NEC addresses wiring and protection, including overcurrent protection and grounding. Article 210 covers branch circuits, which are the circuits that supply power to outlets and lighting. Article 215 covers feeders, which are the circuits that supply power to branch circuits. Article 220 covers branch circuit, feeder, and service calculations, which are used to determine the size of conductors and overcurrent protection. Article 225 covers outside branch circuits and feeders. Article 230 covers services, which are the conductors and equipment that bring power from the utility to the building. Article 240 covers overcurrent protection, including circuit breakers and fuses. Article 250 covers grounding and bonding, which are essential for electrical safety. Article 300 covers general wiring methods. Article 310 covers conductors for general wiring. Article 312 covers cabinets, cutout boxes, and meter socket enclosures. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and manholes. Article 320 covers armored cable type AC. Article 330 covers metal-clad cable type MC. Article 334 covers non-metallic sheet cable types NM, NMC, and NMS. Article 336 covers shielded non-metallic sheath cable type SNM. Article 338 covers service entrance cable types SC in use. Article 340 covers underground feeder and branch circuit cable type UF. Article 342 covers intermediate metal conduit type IMC. Article 344 covers rigid metal conduit type RMC. Article 348 covers flexible metal conduit type FMC. Article 350 covers flexible metallic tubing type FMT. Article 352 covers rigid polyvinyl chloride conduit type PVC. Article 356 covers liquid tight flexible non-metallic conduit type LFNC. Article 358 covers electrical metallic tubing type EMT. Article 360 covers flexible metal conduit. Article 362 covers electrical non-metallic tubing type ENT. Article 366 covers auxiliary gutters. Article 368 covers busways. Article 370 covers cable trays. Article 372 covers cellular metal floor raceways. Article 374 covers cellular concrete floor raceways. Article 376 covers metal wireways. Article 378 covers non-metallic wireways. Article 380 covers switches. Article 382 covers multi-outlet assemblies. Article 384 covers switchboards and panel boards. Article 386 covers surface metal raceways. Article 388 covers surface non-metallic raceways. Article 390 covers underfloor raceways. Article 392 covers cable trays. Article 393 covers low-voltage suspended ceiling power distribution systems. Article 394 covers concealed knob and tube wiring. Article 396 covers messenger-supported wiring. Article 398 covers open wiring on insulators. Chapter 4 of the NEC covers equipment for general use. Article 400 covers flexible cores and flexible cables. Article 402 covers fixture wires. Article 404 covers switches. Article 406 covers receptacles, cord connectors, and attachment plugs. Article 408 covers switchboards and panel boards. Article 409 covers industrial control panels. Article 410 covers luminaires, lamp holders, and lamps. Article 411 covers lighting systems operating at 30 volts or less. Article 422 covers appliances. Article 424 covers fixed electric space heating equipment. Article 426 covers fixed outdoor electric de-icing and snow melting equipment. Article 427 covers fixed electric heating equipment for pipelines and vessels. Article 430 covers motors, motor circuits, and controllers. Article 430.22 addresses the minimum conductor ampacity for a motor. Article 440 covers air conditioning and refrigerating equipment. Article 445 covers generators. Article 450 covers transformers and transformer volts. Article 455 covers phase converters. Article 460 covers capacitors. Article 470 covers resistors and reactors. Article 480 covers storage batteries. Article 490 covers equipment over 600 volts, nominal. Chapter 5 of the NEC covers special occupancies. Article 500 covers hazardous classified locations. Article 501 covers class I locations. Article 502 covers class Roman II locations. Article 503 covers class Roman III locations. Article 504 covers intrinsically safe systems. Article 505 covers Zone 0, Zone 1, and Zone 2 locations. Article 510 covers hazardous classified locations specific. Article 511 covers commercial garages, repair and storage. Article 513 covers aircraft hangars. Article 514 covers gasoline dispensing and service stations. Article 515 covers bulk storage plants. Article 516 covers finishing processes. Article 517 covers healthcare facilities. Article 518 covers places of assembly. Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. Article 522 covers control systems for permanent building installations for use in indoor recreational facilities. Article 525 covers carnivals, circuses, fairs, and similar events. Article 530 covers motion picture and television studios and similar locations. Article 540 covers motion picture projection rooms. Article 545 covers manufactured buildings. Article 547 covers agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks. Article 551 covers recreational vehicles and recreational vehicle parks. Article 552 covers auxiliary buildings. Article 553 covers floating buildings. Article 555 covers marinas and boatyards. Chapter 6 of the NEC covers special equipment. Article 600 covers electric signs and outline lighting. Article 604 covers manufactured wiring systems. Article 605 covers office furnishings. Article 610 covers cranes and hoists. Article 620 covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chair lifts. Article 625 covers electric vehicle charging systems. Article 626 covers integrated electrical systems. Article 630 covers electric welders. Article 640 covers audio signal processing, amplification, and reproduction equipment. Article 645 covers information technology equipment. Article 646 covers modular data centers. Article 647 covers sensitive electronic equipment. Article 650 covers pipe organs. Article 660 covers X-ray equipment. Article 665 covers induction and electric heating equipment. Article 668 covers electrolytic cells. Article 669 covers electroplating. Article 670 covers industrial machinery. Article 675 covers electrically driven or controlled irrigation machines. Article 680 covers swimming pools, fountains, and similar installations. Article 682 covers natural and artificially made bodies of water. Article 685 covers integrated electrical systems. Article 690 covers solar photovoltaic PV systems. Article 692 covers fuel cell systems. Article 694 covers wind electric systems. Article 695 covers fire pumps. Chapter 7 of the NEC covers special conditions. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Article 705 covers interconnected electric power production sources. Article 708 covers critical operations power systems COPS. Article 710 covers over 600 volts, nominal general. Article 720 covers circuits and equipment operating at less than 50 volts. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Article 727 covers instrumentation tray cable type ITC. Article 760 covers fire alarm systems. Article 770 covers optical fiber cables and raceways. Article 780 covers signaling and power-limited fire alarm systems. Article 790 covers network-powered broadband communications systems. Article 800 covers communications circuits. Article 805 covers communication systems. Article 810 covers radio and television equipment. Article 820 covers community antenna television and radio distribution CATV systems. Article 830 covers network-powered broadband communications systems. Article 840 covers premises-powered broadband communications systems. Chapter 9 of the NEC contains tables and examples. Table 310.15b16 provides ampacity correction factors for conductors. Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts. Table 310.17 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts in free air. Table 310.18 provides the allowable ampacities of 3 single insulated conductors rated up to and including 2000 volts in raceway or cable or direct buried based on ambient temperature of 30 degrees Celsius. Table 310.19 provides the allowable ampacities of 3 single insulated conductors rated up to and including 2000 volts in free air based on ambient temperature of 30 degrees Celsius. Annex A provides product safety standards. Annex B provides application information for ampacity calculation under engineering supervision. Annex C provides cable tray fill tables. Annex D provides examples. Annex E provides ampacity adjustment factors for more than 3 current carrying conductors in a raceway or cable with ambient temperatures above 30 degrees Celsius. Annex F provides cross-reference tables. Annex G provides administration and enforcement. Annex H provides administration and enforcement. Annex I provides recommended tightening torque table for electrical connections. When installing electrical panels, it is essential to follow the manufacturer's instructions and local codes. Consider the load calculations for the built-in to ensure that the panel has adequate capacity. Load calculations involve determining the total electrical demand of the building, including lighting, appliances, and equipment. This information is used to select the appropriate size panel and conductors. Ensure that the panel is properly grounded to prevent electrical shock hazards. Grounding involves connecting the electrical system to the earth, providing a path for fault current to flow back to the source. Use the correct size and type of conductors for the panel and branch circuits. Conductor size is determined by the ampacity of the circuit. Ampacity is the maximum amount of current that a conductor can carry safely. Install overcurrent protection devices, such as circuit breakers or fuses, to protect the panel and branch circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a safe level. Label all circuits in the panel to make it easy to identify and troubleshoot problems. Circuit labeling helps to identify which circuit breaker controls which outlets and appliances. Leave space in the panel for future expansion, as electrical needs may increase over time. Future expansion can accommodate new circuits and equipment. Heat the panel clean and free of debris to prevent overheating and electrical hazards. Cleanliness prevents dust and debris from interfering with the proper operation of the panel. If the panel is located in a damp or wet location, install a weatherproof enclosure to protect it from moisture. Weatherproof enclosures protect the panel from rain, snow, and other environmental factors. Consider the use of surge protection devices to protect the panel and connected equipment from voltage surges. Surge protection devices help to prevent damage from lightning strikes and other power surges. Regularly inspect the panel for signs of damage or wear, and replace any damaged components immediately. Regular inspections can identify potential problems before they become serious. When working with electrical panels, always de-energize the circuit before working on it. De-energizing the circuit ensures that there is no risk of electrical shock. Use appropriate personal protective equipment, such as gloves and safety glasses. Personal protective equipment helps to protect against electrical shock and other hazards. If you are not comfortable working with electrical panels, consult with a qualified electrician. Qualified electricians have the knowledge and experience to safely install and maintain electrical panels. Understanding the NEC and local codes is crucial for ensuring the safety and functionality of electrical installations. By following these guidelines and best practices, you can create a safe and reliable electrical system. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. Ensuring proper electrical installations contributes to overall safety and prevents potential hazards in residential and commercial buildings.